No, I was here.
Huh?
I did not know. I was here.
Yeah. Yeah. So I'm watching the animation of water vapor from the University of Wisconsin website. It's very impressive. Next time maybe I'll show the animation. I just now picked up one about this discussion. This is on 21st July. There's a clear indication of a low water vapor has squeezed between two high water vapor. Okay. I would like to know how it came. I don't understand it. How does a thin layer of low water vapor get squeezed between two high water vapor? And here it is Kerala, and locally you can see that there will be a break in the rainfall there. So I think if you look at the animation, you see it comes from the southern hemisphere. But I would like to understand how it goes between two high water vapor regime without getting any diffusion effects and so on. Okay. So I do remember one I didn't fully understand. One of the experts on atmospheric dynamics is Brian Hoskins. He argued that this kind of if you do trajectory analysis, your accuracy is very, very good and nobody is doing that. And he claimed various examples. For example, this debate came more than 10 years ago. Satish had launched a balloon and what's the maximum black carbon concentration at a height of about 7 kilometers. And they couldn't identify any aircraft passing off that height. And Hoskins argued, I didn't fully understand it, argued that air descending from Pakistan, interestingly, comes over India, it will produce a sharp, this one. He says, people don't understand that there are a situation where diffusion doesn't play a role and certain things maintain the trajectory. So this could be that category. So maybe next time it's really more animation of this. And it's really interesting how cold, dry air. It's different from what it presented. It's not from up above. It's from below. Okay. Because air is very cold and dry. And that comes and gets squeezed between very moist water vapor and water in July, when of course it is very moist and Indian Ocean is very moist. In between, this thing comes. So to me, if you do a little more of these studies and if this reaches somewhere here, then what it can be a cause of break. Okay. So this is what analyzing language being done by University of Wisconsin. I'm sure you download the data. I'm not going to do it. You can find out. You can download it. Then you can study a lot of trajectories. Find out when such a low water vapor trajectory comes and hits somewhere here, and whether that leads to a situation where rainfall decreases over India. Okay? Because I'm a great believer that water vapor is a trigger for rainfall. Okay, let's come to what's happening here. So as of today, it's remarkable. The total rainfall cumulative is 420 millimeters. Okay, compared to 399. So always 21 millimeters above normal. So things are going very nicely. And as you know, we don't understand why. There is a very warm El Nino even going on still, not gone away. And except for the little late start in June, July has been doing extremely well. And if you look at this part, July rainfall for country goes 15% above normal. Only a group is suffered by the Northeast, minus 30%. Central they are 26. South Peninsula, the last 1 week, you can see what has happened. It's gone well over now. Okay. So we still don't understand why the rainfall in July was so close to being above normal. Now we have to look further. We have come to the end of the first half of the monsoon. Next week, beginning in August. So let's look at my favorite scatter plot, which is June plus July versus August plus September. Okay. The idea is knowing June plus July, can we say anything about August, September? Okay. Now remember, we're already at 420. So I'm almost sure today is 26, 27, 28, 29, 30, 31, 5 days, averaging 10. You can add another 50, 40, doesn't matter. So we are going to be somewhere here. Okay. So unless something unusual happens, like what happened in 1913 and 2001, where the August September rainfall became very low, Except for that, the impression we get here is that if you're somewhere here in June, July, your rainfall in August at least 380, if not 430 and 480 rainfall. So the question is, whether in the next 2 months, will there be a long break, which will completely spoil the good news we're having so far? And that's not true. I'll tell you why. You mean I want to look at this more closely. All the red points are 21st century. So we started from 1901 to 2022. So we have to get a good color in 2 digits. But I want to look at these in 2002, when not only usually was poor, August was also poor. Look at 2009, similar value. 2014, all these are last 20 years. 2012. See, these 4 events all belong to 21st century, okay? And also the more on that track. So this is the thing we want to understand why these 4 years were quite poor both in July and August September. There was some recovery here, but it was not enough to recover. But today, this year we are actually somewhere here. So the chances of a drought is somewhat low. But I would not rule out below normal rainfall, maybe close to what IMD saying 6%, 7% is still possible. Okay. Now we come to the most puzzling part, which bothers me so much that I think I made an error. So all of you can check whether I made a mistake. Okay. So I looked at the anomaly of rainfall in the 22 days data for July. Okay. And the most interesting part, of course, you know, for India rainfall was crazy. And notice that there is a dry patch here. Kerala has been very good, low rainfall. I'll show you that. The Indian one is not this that the rainfall is high over India, but the rainfall is high over India. Now, this to me is completely counterintuitive. See, when you talk about all this talk about El Nino, water circulation, everybody agrees that during the 3.4 was the anomaly, air rises over 3.4, it sinks over Indonesia. Okay, read any paper. This is given as a theorem, the known. Okay, this year it didn't happen, and I don't know why. There is no logic as to why, if the air is so warm here and rising, why is it not sinking over here? Which is what we're all taught. Textbooks, papers, all swear by the fact that water circulation anomaly occurs during El Nino year, and air sinks over Indonesia and rises over this one. And I can give any number of examples of years where it happened. This year is not happening. Now, it's not clear why, because this part, see, India not being affected by water circulation, understandable. So link between water and circulation outside the tropics is much more complicated. You can talk about IOD event here, you can talk about something else there. But from the equator, the dominant circulation is water. There is no hardly there. Okay? So we should have a simple theory, and that theory is not working. Okay? The question is why? I think I want you to notice that this year, all the anomalies are occurring around the equator, and off equator it is all positive, including Kerala. Now I want to remind you, before I forget, there's a whole set of papers published about 10-20 years ago, where I forget the name of the person, she's been followed up. So she argued that defining El Nino through SST is not the right thing. Okay? And there's not picked up. It's a very profound idea. She's saying using SST as the criteria for El Nino definition is misleading because an SST anomaly does not always produce a convection anomaly. And so she has written a series of papers in which she defined El Nino through OLAR. Okay? OLAR based El Nino. Okay? And she shows how it removes a lot of disturbances. Now, I personally am not very happy about it. Why? Because OLAR, of course, is an indication of convection. But unfortunately, it's a very noisy variable. So it's not like SST I like because it has a persistence. SST normally is positive in July, it is positive in August. It will take some time to cool down. OLAR will change from week to week. So I don't know how stable her definition is, but she has a profound point that unless there is anomalies in convection in the atmosphere, El Nino will not work. That is the I'm talking about the teleconnection mode. You can still define El Nino based on SSS, okay. But you want to understand the El Nino teleconnection, you use the OLR as your index. So next week I'll mention those papers. I didn't have it right now. So those papers are worth reading because she redefines El Nino only through convection, not through SST. Now, why I'm saying all this is because this is what I'm normally used to seeing. There's a correlation between Nino 3.4 and rainfall in the tropics. Okay, this is the classic picture. All of you know it. The correlation, of course, very high here and positive along the Nino 3.4 naturally because higher temperature, more rainfall, and so on. And an interesting arm of positive anomaly here. And just to the just below it, there is the negative correlation. That is drying all the way Australia, Indonesia, and part of India. Okay? So this is the standard El Nino response, and that is not occurring this year. That's the point to figure out why it's not occurring. Why this kind of thing with correlation shows is the majority response is missing. Okay? Now we come to now the same thing. I've done a close up here to highlight the Indonesian part. Same thing. I'm just taking a close up that. Now this one is composite of all the drought years, which are El Nino years, and this is what I call canonical thing. Descent over Indonesia, descent over India, ascent to north of Indonesia, and ascent over the equator. Okay? So this canonical response is not working this way, and I don't have any reason why. This is what this is very anomalous here. This standard response with every El Nino breaks did not come here. You cannot hide behind IOD. IOD is not yet there, so we have to give some explanation what is doing. I'm not able to find, except that I found one thing last evening. I'm not fully understood it. Happened in the southern hemisphere. Okay? The southern hemisphere jet will normally remain somewhere here and move here. But I don't care how that jet moving here will happen. I don't know. So I'm not studied it. I don't see any paper on it. So that is the only anomaly at all in circulation that was visible the last 3 weeks. Now, one more anomaly is the northward migration. Now, if you look at the omega field, this is the not anomaly, actual value. You see that in the month of June and July, only thing that happened is not the if I can find out, there were two events hitting northern migration. Okay? Nothing occurred on the equator or the equator. This is also very rare. Normally, things start south of the equator, well, you see that move all the way to India. I don't see it at all this year, and that also is very peculiar. I don't understand what that's causing. Okay. I think this is a repeat. I think I got a couple of. Oh, no, I think I'll. This I already covered. Okay. This only want to show you this thing. What's happening here? South of Australia, the jet movement has caused an anomaly in rainfall here. So that is, I'm not fully figured yet. I will say something next week when I say something there. So as far as I can see, the only thing which is unusual this year is in southern hemisphere. Northern hemisphere, there's nothing occurring which can explain the unusual behavior. So all of you can think about it. It's an interesting phenomenon. Now let's look at Kerala. When India is having floods in North India and in Maharashtra and parts of Karnataka, Kerala is mostly deficient. Okay. Now this is a very interesting issue because we did some work a long time ago with my student Rajendran with a Japanese model in which it was clear that due to global warming, the jet shifts about 10 degrees northward. So this year also jet is to the north of the normal position. So the winds in Kerala are lesser than winds in Karnataka and Maharashtra. So the moisture coming to Kerala is less. And this is happening year after year, except 1 year when, of course, Kerala had a flood. If you had that particular event, Kerala rainfall has declined for the last 50 years. Okay? Now he talks about it because Kerala is a region of high rainfall, so nobody worries about it. But I'm sure from the point of view of ecology and climatology, it's a serious issue. If over the next 100 years rainfall keeps decreasing, it will have a huge impact on the ecosystem of that area because it used high rainfall. Okay, let me see what's going on in the next few weeks. There is a hint of a break. This is from Q, starting from this week. Already the hint that there is going to be a break in a few days, according to this. And next week is completely below normal. Okay. So, so I think there's going to break going to come. And one can ask whether the break is related to either dry extrusion or some other phenomena. Can think about that. This is from okay, this model. Okay. Now, you remember this model I had earlier projected. Now, this is based on June in its condition. They made a forecast, thank you people, and they showed that August will be below normal. Okay. But they're pretty much July not too good. They are doing high rainfall in Kerala. That didn't happen. And they didn't get spotlight. So that model is still has some doubt. But they're saying both August and September will be below normal. Okay. So keep that in mind the next few weeks. What are they saying with the July initial condition? They are changing their mind slightly. September may be normal, but August continues to be going to be not normal. Okay. So this is what we are going to watch out next 1 week. How whether the unusually active days we had for almost most of July will stop and we'll get into a break phase. And we can ask, looking at the animation done by this concept, we can ask whether attraction of water vapor plays some role in it or not. That we can look at. Okay. Now there's also a hint from the CFSV2 forecast that in the next few days is going to come down. Okay. It is not, I think I got up to today, somewhere here. So yeah, this is not right. This forecast is not right. So we are getting numbers around this value, around 10 millimeters per day. It is lower than 44 in the 21st and 20th and 23rd, but it has not come down below the kilometer. Now, let's see the next forecast of that. The next forecast is that it is going to go on this board. Let's say next week whether this one comes through or not. The decline in the rainfall. Okay. Okay, I'll stop there. Any question? And do you remember that person who had this different? We discussed that long time. I remember. In one of the monsoon campaigns, 4 years, 5 years, discussed on this. I have to go look it up. And so if you define according to that criteria, it may not be any of this. So that's the fact. Only is the atmospheric parameter. I'm not very comfortable with it because it will change every few weeks. Like certain oscillation. So until we have good SST data, everybody is using SO. So it's very noisy. Being atmospheric parameter is going every 2 days fluctuating. So all of that problem. But here's the point that since we not really understood the connection between SST and OLR in the pressure position, you better use OLR as a criteria to understand telemetry. So, but unfortunately, now you have people who believe that so that the paper not get cited. But I think share some new insights. I'll mention paper next week and we'll look at that.
The problem is the forecasting.
Huh?
The problem is the forecasting.
Yeah, that's it. Yeah. What are the issues? For OLR, we consider like crazy. But understanding the connection, I think OLR is much better one than SST. Okay, everybody.
When you say we don't understand why this is happening, mentioned why the rainfall is so high.
Yeah.
But initially, before I remember reading that IMD had predicted that this would happen.
Yeah.
So they,
But you know, they didn't tell my problem is that I'm a forecast. But
that means the models they're using, they are able to understand what is happening on that.
No, that not discovered. Anti-policy is not about what. See, IMD they give you is based on the committee literally both the vertical model and the diagonal model. And they got something. And the second they count how they correct that. That is not that. That's very important. You can get it from nothing happens. You must not do that. So I don't know why they don't know they fall. They think it is very close to specific and and whatever is not, that's possible. Or yeah, some other inside we don't have. Or the political model gave some, because there is a, the final process is dominated by certain language. They don't trust any one of them, understand, neither is good. So there's a lot of description and continues to arrive there. That's why it is a particular activity. But from an academic perspective, it's about the reason why they're proposed. Because if it's purely with the chemical, you can put alcohol in it and such like that. If it's purely with the physical, you can say we have over experience with this. But you don't think it is a problem. The reason I think all this because it was older, that before the famous 2014, 2015 broadcast of drought, IMP tended to always give nowadays. And that is based on the caution that it is sort of the time. Look at the country, right? So that makes it clear. I mean, we used to make fun of it, but now that I've learned everything, I will make fun of it. For example, so the Joseph, one of the most leading forecasters in India, mentioned that when he was in Delhi airport, he has reported to the fire. And even with the smallest chance of thunderstorm, you tell them we have the thunderstorm. They'll come back and open. I'm saying all these forecasts, including the running on the pilot, we told what was the forecast because both of them not there. So Joseph thought, what? I'm a forecaster in the airport. If I say thunderstorm, not a and if it occurs and there's a big crash, it will be changed. I don't know that how seriously job is not very serious. And he told the story, I think he recorded it. There was a famous crash in Delhi of aircraft near the Minister Line, one of the and everyone worked with the whole story, 1974. And this occurred during a heat wave, not during a thunderstorm. And Joseph was there area for some time. And he was, and you know, when this crash occurred, yeah, international flight. And so when the crash occurred, there are all kinds of competing parties involved. One is airport company. They don't want to blame for it. And of course, the airport people who do the airport controller, they are also in this because all the three involved. So and of course Indian Cabinet. So fine. So everyone tried to defend their what is called stuff. So he told me that before, and before he did a very funny rule. He was trying to stand for 8 hours no sitting. I don't understand this. He said it was very painful. And he said, so we were in weather forecasting. How to make sails and predict conditions which may not occur most of the time. So if you make one mistake and the reactor, we will be dead. So if you understand that environment, then you know why you do it. I didn't know it earlier, so I will make fun of that, but now I understand forecast scenario, especially for control situation. So you have to make safe. Small example of underground, let's be careful confirm with that. Tomorrow anything happens, not. And what is very important, my father was doing aviation a long time ago, and he told me that time, he told me that that crash only occurred because of a heat wave that is a low pressure in some areas. And the pilot was landing, it didn't allow for that aircraft to drop. I think it dropped. I think Yamana, it actually crashed in Yamana river bed. So this problem in India, after April, May, it happened. There is a local heat created low density area. And a pilot who is landing the plane has to allow for that. Like allow for here, to make it allow for the low pressure. And I was told that these guys did not do that. Then they have about few earlier, from Delhi to Bombay, crashed near Haveli, Delhi. I don't think that crashed. So this always occurred within May. And I don't know why I didn't do from that well, but global for me that you guys don't know what this is subjected to what an airport technology. So they always make, so certainly, the level of the government, they want to make clear. And let us show that 20% of the time, job will not occur. You are better off. There are traditions for a long time. Again, only in the last 10 years, their confidence in PCM went up. They started making more forecast. But forecast ruled out that if the model output is not giving clear message, you take no. That's logical. So that's what I think. But I mean, somebody would come and let's wait for the season over. I thought some people said that they can come and tell us what exactly kind of picture for them. Because we, these unusual are the ones which teach you normally there is a both, but there's nothing to learn. Because one is normal most of the time. But it is drought gets the pressure, which will give you some good fact, is the phenomenon, which is the main interest for academic. So that's why we have to keep communicating the unusual. So this year I would say the most unusual. All of you can do your own analysis and data as well as if you see anything unusual correctly. Because to me, the only thing that can explain the difference between this alien all the alien something in the circulation regime is different from that we will do. Otherwise, the normal things would have, right? So we are not able to figure out what it is. And it remains surprised because this is why I feel very guilty. Because 20 years ago, I could have blamed lack of data, lack of satellites. Now I cannot say anything. There is no satellite, everything is there. If you're not able to figure it out, we are damaging society. So this is something all of us think about. How come so much data available? When the analysis is done, why not able to explain why these things get different things and other things? Now, I don't know you to July. We'll see what happens next month. So the month of July, if you do the analysis for all July, the last 30, 40 years, good data. Then you know already mentioned. You don't know. Except that is some, there is of course, and here it's IoT is involved. IoT is still not, okay, I think I just have to figure. I have not have a figure, so you edit. IoT is not yet, yeah, I'm sorry, I don't, IoT has no sign at all. As a matter of fact, last time I showed you there is a negative anomaly along the Somali coast to the Appali, and then a positive anomaly along the Sumatra coast. Actually, it's a negative IoT, not positive right now. It may change, but right now it's not a positive anomaly. It looks like a negative anomaly. So the coastal regions of Somalia are cold, and coastal Sumatra shows a warm and quite warm. Okay. Thank you. So who is next week? Huh? Huh? Okay.
Jace, can I ask a question? Vishal here.
Sure.
Yeah, so actually my question is about the image you showed for pivot, and thanks a lot for actually reminding us about the variability in pivot. I was wondering your observation that dry pockets exist and they retain identity. That particular observation, is it only close to the Somali jet, or you think it's in general the feature of tropics?
I have to check because what we have to do is look at the, I'll ask Rajat to do it. Take that figure and put on top of it the jet position on that day, that is 5 days back. Let's see how close it is. Is it along the axis? That I doubt it. I doubt that, but yeah, one should look at it. I think that pivot animation should go along with the animation of, but one thing I tell you, that pivot animation is very interesting. You know why? Because they use wind speed for that. Yeah. I mean, it is done with wind speed. So, but yeah, you have to understand where the maxima of the jet is and where the pivot anomaly is. Yes. But I don't think it is anywhere near the jet maxima, which is closer to, as I pointed out, it's closer to Karwar or somewhere. Jet is nowhere near that Kerala. Kerala is where that low pivot is, right? We are nowhere near it, right? The jet. But what you can superimpose that and show that.
Right.
Actually, I would suggest somebody, I'm not able to do that. Somebody find out from that website how to download the data and do the animation more closely and see how it is. Data available, but I don't know how to get all the data. Okay.
Okay. Yeah. Thanks, Jace. Another comment is, I think you were mentioning about Hui Su. I have pasted the link to her paper which you mentioned. kind of ENSO link to OLR versus SST.
Yeah.
It's in the chat.
Huh?
I have
Who is that?
pasted the paper in the chat.
Okay, okay, good.
Yeah, thanks.
What's the name of the author? That's important. Huh? No, it's not Hughes. It is, I'll tell you, some other name. She's a woman, and of course, this could also be a woman's name, I don't know. But it's an American, not a Chinese name. Okay.
No. So
I'll
she
tell
worked
you,
with David
I'll-
Nilin, Jace. She worked with Nilin, and
Okay.
it's a lady. So I was suspecting you are referring to her.
Yeah, that, I mean, the others may have worked, but this person is in either FSU or in Miami, one of these places, if I remember correctly.
Oh, I see.
I'll
Yeah,
go on,
she's
okay,
in
just
Jet
tell-
Propulsion.
Here's
Yeah.
the email. Okay, yeah.
Okay. Yeah.
Okay.
Thanks.
Thanks.